Why do you think you need to study statistics? Open floor, talk, raise your hand.
We live in a world where we don't have good, complete data that's always secure and always the best thing possible. We're messy people, messy sensors, messy data. It helps us make reality out of it.
Okay.
Rules and systems that we can use to make predictions.
What is your name?
Sam.
Sam, nice to meet you. Great answer. Oh, yes,
Me.
yeah. You were raising your hand, right?
Yeah, I was.
Yeah, good.
For me, just to lie about statistics, especially like companies lying about the quality of their products.
Oh, okay.
So,
To detect BS, essentially.
yeah.
You know. Yeah. Okay. Why do you want to study statistics? Okay. It's like more probability. I don't recommend gambling, but you know, yeah, you can use statistics and probability to help with that. Who else? Like obviously you're here because you are required to take this course, but I hope that you're not taking this course because you are required to, rather that you agree that you want to take this course. So I want you to want to take this course. I want you to want to take this course. What else do you think? Why do you think statistics is important?
It can lead to like efficiency of different things. You can understand like certain shopping patterns, like make things more efficient for people.
Okay. Sorry, I forgot to ask your names.
I'm Mark.
Mark. My son's name is Mark. Best name ever, you know. Who was it? Pardon me? Okay. Okay. You had it?
I'm Alex, and so that you can better understand your data, how your research or your data might affect people, and to make predictions about the future.
Very nice. Very well said.
A lot of like chemistry is statistics. Like whenever the physical stuff is small enough, then it's like
Statistical thermodynamics, your kinetic theory of gases. What's your name? Adam. Okay.
We need to understand it so that we can kind of predict trends in markets. So depending on our job, we might need to produce certain things at certain times.
Looks like you have some investments at stake, right? What's your name?
Logan.
Logan. My son's middle name is Logan. Best name ever, Wolverine. Okay.
You can use it to kind of like double check your work. So using statistics, you can figure out if certain data is an outlier and figure out why that could be bad data or why it could be
Correct.
useful.
Correct. What's your name?
I'm Jaden.
Jaden. Okay, I don't have a son named Jaden, but literally Mark Logan, that's my son's name. Don't advertise that information. Okay, who else? What else? What do you got? Sorry, I'm a little low voice this year because I'm not 100%, as you can see, but if you can't hear me, you feel free to come forward or I'll use the microphone. All right, so yeah, you are all correct. And I will give you my take on this and why I think it's important and why I'm probably your best instructor to do statistics because I am not a statistician, okay? I'm a very good mathematician and engineer. I like to think so, but statistics, I never formally studied statistics. And in your life experience, you will know that the topic that you will teach best is the topic that you have to learn yourself with your own due diligence and asking questions. So that's why I think I will do a good job in this course to deliver to you why I think statistics is important and the tools that you need. We'll talk about that a little later, but here's my take on why you should study statistics. There's a common theme that I heard from all of you. There's prediction, there's detecting BS, there's et cetera, all of that, but there's the word data that kept coming up, and that's true. You need to study statistics because of data. Everything is data, especially in this day and age. Some people think AI was like, oh my goodness, this is like the most miraculous discovery. It was the time for AI to come because there is so much data in the world. We're generating so much data, so much information every day. It's really hard to make sense of any of it. Think of your photo app. In the past, believe it or not, I grew up with film cameras. I'm a millennial, like right at the borderline of millennials. And I had my first camera in Nikon N80. It was a film camera, and you know, every time we had to go to the store, buy a film, put it in the camera, wind it. We had 36 or 24 pictures, and then you have to go and give it to someone, call the president so that they develop the film, come back a week later, and it's all burned up. But then you end up having like maybe your lifetime 200 pictures or 500 pictures that you enjoy and cherish, but you know each and every picture. Now you look at your phone, in a month you have over 3,000 pictures maybe, if you're like me, like taking pictures all the time. But now go figure, where do you find that picture that had, like, when your kid had that green frog that they want right now, but you know, it was 2 years ago, and you're like trying to remember, what the heck are they talking about? And you're scrolling through your pictures and you can find it, and you drop your phone, you're like, screw this. I don't want to look at the pictures anymore. Then comes Google Photos, right? And this has this smart search, and you can say frog. You don't have to worry about sorting your pictures anymore or thinking about them. You just have pictures, 7 million, I don't care. Frog, give me all the pictures that have frog in them. Green frog, yellow frog, right? And so AI is helping us sort through all of that data. But the foundation of all of this is statistics. Now, statistics is the best tool to help us make sense of data. There are two things that I sense here. There's making sense of data. That's what we're going to call descriptive statistics. We're going to look at data and see how beautiful and pretty it is, and we're going to get descriptions about it. What is your mean data? What is the median about you, Mr. Data? But then, that's not the only thing we're going to do with data. We're going to take data and we're going to say, hey, data, can we make a prediction from the little data we have? Going to collect some numbers about heights, maybe here. Can I make a prediction about the heights of people at the University of Utah, like how tall they are? Right? That's going to be called inferential statistics. It's kind of trying to wet your beak a little bit. Now, I'll give you an example first from my own house. So who knows about radon? Who's heard? Yes. Okay, you must be Utahns, right? For those of you who haven't heard about radon, radon is a radioactive gas. Did you know that Utah is among the least smokers in the United States, in fact, the world? Like, have you seen a Utahn who doesn't skydive or like climb 17 mountains a day? It's really like puts a lot of pressure on you when you move to Utah. But they don't smoke. People in Utah do not smoke, yet they had, last time I checked, the second highest rate of lung cancer in the nation. Why? Because of radon. Radon is a naturally occurring radioactive gas that happens to be very prevalent in the Mountain West, especially in Utah. So if you go further towards the cottonwoods, the canyons, the mountains, there's more granite in the ground, and granite has some radioactivity to it, and it helps emit this radon gas. Now, because also the nature is very sandy, the soil is soft, this radon comes up through the cracks in the soil and ends up making it through your basement in your home. Okay? And typically, the highest radon levels are found in people's basements. And this is the case for my basement. Okay? This is the radon in my basement. Okay? Now, why does it come through the basement? Because the basement slab is closest to the ground. There are some cracks in the concrete. It seeps in, comes through. There's pressure changes in the atmosphere. Sometimes when there's a high pressure storm outside, it tends to push the radon out, and then you have to open windows, etc. But what you're looking at here is 1 year worth of data where I'm plotting, on the y-axis, the radon level is measured in picocurie per liter. Curie, Marie Curie, she was the one who discovered radioactivity. So we honor her by measuring all radioactivity in Curie. So this is picocurie, very little per liter. And these levels fluctuate, as you can see, over time. So this is daily. There's 24 data points per day over an entire year. From September 2023, I can use this as I never thought of that. Okay, from September 2023 till September 2024. Okay, October, a little bit into October. It's a lot of data, right? And what we can say about this data is it just changes a lot, right? But it's very difficult to reason with it. correct? It's really difficult to reason with it. What would be better is to do some what we call descriptive statistics about it. Like on average, what is your radon level in your basement? I spend a lot of time in my basement because I was silly enough to build an arcade system for me and the kiddos, because I want them to have a social interaction when they're playing with me, and my wife and I gang up against them, and we're like playing Mortal Kombat and some other old-fashioned games, or even I have dungeons also hacked into, like this traditional kind of Switch setup, and we spend a lot of time there, and I don't want any of us to be breathing that, okay? And so we wanted to know if we're gonna die or not from this. So, I looked at the data, I'm like, oh, yeah, maybe those peaks are occurring, I don't know, at night, I'm not there, maybe it doesn't matter, right? So I plotted what's called a histogram of the data. So looking at how often do these peaks occur, okay, and how often do the low levels occur. And so this histogram makes a count of how many times we've measured certain values. So for example, you look at the x-axis here, I'm plotting radon levels from 0 to 10 picocurie, because anything above 2 is really dangerous, can be considered dangerous, okay? So if you look here at these bins, for example, like if you look at this bin where I'm right around level 2, right? There's about maybe I would say 175 occurrences of this level, or 175 measurements at that level. Then you look here at the peak, there's about 360 measurements at this level, maybe that's about 1. And then, you look at the higher levels, it's reassuring that, there's not many of those at the higher levels, but there is quite a bit. Like I said, anything above 2 is concerning. So, starting from here, there's quite a lot, almost 140 hours exposed at, between 2 and maybe 2.1 picocurie per liter. That's not good. That's not good. So, given that we are mature adults, we thought we were all going to die, and that we needed to do something about it. We didn't tell the kids because kids do not handle this well. But I'm dramatizing the story. But we thought like, okay, well maybe we should do something about it. So we asked around, and we said, can we do something about it? There's this thing called a radon mitigation system. Who has one in their home? Everyone? Okay, great. All right, I'll show you how we installed ours. So it's called a radon mitigation system. What they do, they come and dig a hole in your utility room. I made sure to clean it before I took this picture because I wanted to show it to my students. So it's usually a mess filled with spiders and all kinds of crap. Anyway, so they dig a big hole here in the slab, and see the slab, this hole, they took it out. Of course, my kids were interested in this, so I still have this for some reason. They try to destroy it, and all they make is more dust and things I have to clean up. Anyway, they dig a hole, and just under there's sand. And they remove some sand with their hands, and like I'm helping them remove the sand. I live in Sandy, small town in Sandy. Not a small town, it's pretty big, but it's sandy for a reason because there's sand everywhere. It's very sandy under the concrete. So the sand was very soft, so we removed it. And what they're gonna do, they install like this PVC piping and they seal it, right? And they connect it. And I designed this setup. I told them they were gonna put it exposed in the middle of the basement. I told them over my dead body, I need this hidden. So I found a way where we can kind of sneak it in under the utilities here, and I'll show you in the next picture how we kind of popped out into the garage from there. And so this is a very long PVC pipe. You see this is connected to that utility room, comes out, and they have to put this thing here for fire, whatever is fire code. And then they make a turn for backflow, and then it goes all the way through the garage and all the way to the outside. And the outside, they have this suction pump. So this pump over here is constantly running, just like this noise. Provides suction. So the radon is going to want to move through that spot. So you have a 1,000 square foot basement, one hole in the middle, right? The radon is going to find that's the easiest path to escape. I'm not going to escape through cracks. I'm going to escape through that hole. Comes out, and pop, we eject it into the atmosphere, and it's fine. In the atmosphere, all of us are exposed to background radon radiation. In Utah, it's not concerning at all. Okay, so you're fine. So we installed this system, and before installing it, if this was going to cost us $20,000, I probably have said maybe not. Maybe we'll monitor more. We get better data to really measure if we're exposed to that bad level, to very bad levels. But it was like $1,200. And guess what? We installed it in the winter where they have a slow season or whatever. They give me a call. They're like, oh, we'll give you 50% discount. Like, come install it right now. And so they came and installed it. And so, it was nothing. Like, you wouldn't risk your life for a small cost, relatively small cost, right? But did it work? Okay? Here's the data. I love data. Who doesn't love data? If you can measure something, Sam, you think it worked?
It looks significant.
Do you think it worked?
I would say it especially worked because normally you have radon peaks in the winter.
Okay.
So the fact
We have a radon expert here. What's your name?
I'm happy.
Abby. Okay.
I also live in San Diego.
Oh, okay.
I was looking at the side of your house. I was like, that's the same color as mine. But normally, like at least at my house, we have radon peaks, especially in the winter.
Yeah.
It's cold just because you don't have like your doors and stuff open. As much. So
And you have the weather systems as well in the winter. You have these high pressure systems, right? Okay.
you normally get really, really high peaks.
Yeah.
That's when my dad doesn't let me go into our TV room.
Just open the window and put a fan. Yeah. Yeah. You're a Utah. It's like my kids run outside. I'm from the Mediterranean, so my kids run outside pretty much butt naked, and they're like in the snow, and I'm like sitting inside freezing, like, oh my God, how can we raise these kids? So,
But yeah, those are great numbers.
okay. Look, I am inclined to believe that yes, okay, that this is good indication that, okay, if you can't tell yet, this is the date where we installed the radon mitigation system. Levels did drop significantly, and that blue line is the EPA recommended line for, it's like 2.4 picocurie per liters. So if you're below that, you're at little risk of developing lung cancer in the long term. So yes, the levels did drop, but I'm not convinced. If you are a good data analyst, if you want to be rigorous as an engineer, yes, the trends are promising, but this is not good enough. You cannot say that this is sufficient evidence that your radon levels have dropped. You need to use statistics to demonstrate that. And we're going to learn how to do that. I'm not going to give you the answer. This will be a homework assignment. Okay? We will do that with what's called hypothesis testing, because what if this just due to random chance? Can you prove this is not due to random chance? Maybe we can go run an experiment, turn off the pump, turn it on, turn it off, and turn it on, and see. But there's a lot of factors affecting this. There's weather. You cannot control the weather. Like, if you can control the weather, I'll give you a Nobel Prize. That's like my dream, to control, because I want it to be always nice and springy and sunny, all the time. Maybe one day of winter, and that's it. Okay. So we go back to our why we need. So far, it helps us make sense of data. This is a lot of data. It's all over the place. It's ugly, with mean values. I didn't show you the mean value actually. So here, I didn't mention this first. Come on. Sorry. Go back. Oh, where is the mean value? It should be somewhere here. Okay, there you go. Yes, so my average over the year was 2.81 picocurie per liter. So it's not, they tell you this is not very high. But what if I'm downstairs only during peaks? Then my average is going to be maybe 10 picocuries per liter. Because I go down, I play my guitar every night at 10 in the evening, right? And what if those peaks occurred just at that time? That 15-minute every day. So, it's good, but it gives you a sense of the data, and then we'll learn. You probably know what the standard deviation is. We'll learn about that more And the median tells us like half the data lies below this number. So what? 8,700 data points I have here. About 4,000 of them lie below 1.73, and the other 4,000 lie above 1.73. So these numbers, meaningful statistics, help us understand this very noisy data. Okay, so let's go back. Turn this off. You guys hear me okay? Okay. I get tired easily after all of this, but hopefully be recovering. Maybe you can track my recovery throughout the semester and do statistics on that. Like Professor Saad got tired less and less throughout the semester. And then make a plot for that. Okay. A few other points. Because you need to be data literate to succeed in your career. So I want to take this opportunity also to promote and to plant an idea in your head. You are getting your degree in chemical engineering in general, right? I'm really honored to be an engineer and to be here in front of you. And it's a very honorable profession because it makes the world work. Nobody can argue. It's a profession second to none, in my opinion. Maybe firefighters come first, because those people like give their, sacrifice, etc. But you need to be data literate if you want to succeed. And you're not getting your degree in engineering to get a job. You are building a career. There's a huge difference between getting a job and building a career. The fact that you are here working on this advanced degree, you are working towards a career. That's a life commitment that not all people are going to understand. Okay? You're going to have friends who have jobs, and they don't understand why you're up at 10 p.m. working on a project because you're so excited. You got an idea. You're going to fix this. You're going to save your company $1 million. You found a cure for something. You find a procedure to do better drug delivery in the employment you're working at because you have a career. Okay? As an engineer, you have a career. You don't have a job. Now, in that career, you need to be data literate. You need to, especially in this day and age. If somebody comes and talks to you and tells you, well, the p-value here for these data is 0.1, you need to understand what that means. Okay? Oh, we use the central limit theorem here because the means all converge to a normal distribution. You need to understand what that means and how they did those statistics. Right? You don't need to be an expert. There's one course on statistics. Hardly I can cover anything. I can barely get to analysis of variance of multiple parameters, but kind of sets the initial condition for you to know what's out there. Okay? So you need to be data literate. Also, if you want to destroy your opponents in an argument, good stats make you win every argument. Who doesn't want to win, right? Now, if you're up against each other now, because you know the rules of statistics, it's going to be a little tough. But like with your other friends, you can always come up equipped with good statistics, and you can win every argument. Who doesn't want to do that, right? It helps protect you from what we mentioned earlier, misinformation and bad studies, advertising, etc. We'll do some examples later. And it's really hard when you're faced with things in life changes, you're faced with an illness, you need a certain treatment, and there's like a paradox of choice of treatments out there. Somebody, God forbid, has got cancer, and there's like, oh, surgery, there's radiation, there's chemo, and you look at the statistics, and you get so confused. There's a study coming out every day. You need to be able to reason through these, right? You need to be able to reason through these things and understand what the studies are saying. Finally, and most importantly, is to help you make decisions, okay? And those are going to be there will be some light-hearted decisions, lightweight decisions on your life, maybe. Which car you buy, you can change it later. Which guitar you buy, which shoe you buy, whatever, right? Two very, very important decisions, should you shut down the plant if you're the plant manager? Hopefully one day, should we shut down the plant given this information and furlough everyone, or given some information from the samples that you're building or something, right? So, there might be very severe consequences to your decisions. But I also will take this opportunity to tell you that don't be a data nerd, okay? Because decisions are not only about data. Data and statistics, they kind of give you an idea of, I like this analogy a lot, they kind of give you an idea of what a map looks like and where you are on the map. But only through wisdom and knowledge and ethics and thinking that you can make a decision. So data alone, being blinded by data, you can make a very unethical decision. Like, go check the STAT talk about AI. They told AI, what is it, save the earth or something. It ended up killing all creatures on earth to save it. That's terrible, right? But AI is driven purely by data, right? AI is driven purely. So don't be driven purely by data. Don't forget wisdom and thinking, and that you're a human, okay? And you're working with other humans, you're working with other creatures. And the best example I give, which you are this generation actually that was affected by this, very likely. During COVID, my kids were affected by this. So my oldest son has esotropia. Anybody know what that means? It's eye crossing, okay, fancy term for eye crossing. And he needed to wear special glasses while he was in daycare, while we were trying to work here at the U during COVID. Then it was shut down, and they were masking all the kids, and then they, and then his eyeglasses started fogging, and they refused to take the mask off, and then one day he fell, and the glasses broke. Now, thankfully, they were like made of very special material, but they cracked, but they didn't go in his eye, and I lost it at that time. Which, when somebody gets too close to you, it hurts a lot. And during the COVID study, early on, during the COVID pandemic, people were scared, right? Granted. Everybody was like, okay, let's just kind of freeze, let's shut down and just hang out and see what's going on, take it slow. But then over the first few months, data started coming, and kids, especially elementary school kids, they were not at risk. It was very, very rare that a child would suffer severe consequences from carrying COVID. They were more likely to be affected by the flu than COVID. But despite this data, all schools got shut down. So this is an article from the UNICEF actually about, I picked that, 1.8 trillion hours that students lost from being in the classroom. The cost on students who had even the slightest special needs, right? Whether they want to see a teacher verbalize because they have a speech impediment, for example, or just us being able to talk to each other and see me move and see our body language and all of that. That's what a human is. That's what an education is, right? And we've seen this as university professors, class after class after class, about the impacts. You see the effects on arithmetic, on writing, on establishing rapport with the students, on socialization, right? So that had a huge effect. And I think in retrospect, and the studies are coming out now, and I don't need a study to tell me this because I have common sense. Like, of course kids are going to be affected, if they don't come to school, if they're sitting over Zoom. Imagine a 5-year-old doing a kindergarten over Zoom. It's like they need to, to work their fine motor skills. They need to interact with their other friends. They need to socialize. So it doesn't need rocket science to understand the wisdom behind this. So I think they could have been wiser. These governments who shut everything down. Okay, so first 6 months we shut everything down, but now we have data. We can understand that kids are not a huge vector for the disease. And we did a study on COVID as well for the Utah Symphony. You can find that on NPR. It's a fun interview. And we talk about that study. You can find it on my YouTube channel too. But anyway, it was a huge effect on the kids. And that's an example of where data could, decisions without wisdom can have severe consequences. Okay? Well, let's begin. This is chemical engineering, 2550. This room is 2250, interestingly. I like the closeness of the numbers. So make sure you're in the right class, actually. This is, okay. My name is Tony Saad. Please call me Professor Saad or Dr. Saad or Professor Tony. I probably will not, if you send me a message with like, hey, Tony, probably will not respond to you. So just make sure you call me that. Today, I wanted to get to know you a little bit more and you to get to know me a little more. We'll take it easy. We'll do some administrative and syllabus stuff, talk about the perspective and a little bit deeper discussion on statistics. We're going to argue a little bit whether we do Python. Well, I'm going to argue in my head whether I should do Python or Excel. See, you came from numerical methods, right? Okay. Well, I taught that class for the last 8 years. Last year was the last time I taught it before Professor Yachao took over. So I used to, be the Python, connection in the department. So anything you need in Python and stuff, excuse me. I have a great affinity towards Python. I love Python. So I'm always inclined to do statistics with Python. But for the statistics it looks like it's a hammer. It's like using like a hammer to hammer a small pin, right? It's not, I like to use the right tool for the right purpose, okay? But I promise you there will be some Python, especially when we get to demonstrate what's called the central limit theorem. We're going to do some statistical simulations together, generate some random numbers and do statistics on them and demonstrate what's called the central limit theorem. It's like the greatest theorem. It's not a theorem, it's like reality. It's like, in a nutshell, everything tends to be a normal distribution. And we'll explain why. Why everything tends to be a normal distribution. That's the central limit theorem. And then talk a little bit about my teaching philosophy. First, I'd like you to take a moment. If you have, grab a piece of paper. I put your name on it. Use like a good font size, please. My vision is bad. So it's easier for you to remember 2 or 3 professors' names. You're going to have to remember 60 students' names. I'd like to remember all your names, but I might not be able to, but I definitely will recognize your face, okay? And I will say hi to you when I see you in the hallways. I hope you say hi back, okay? All right. So we'll start with the boring but important stuff. The syllabus is like the contract between you and I. Just in case, something goes wrong, right? We need to establish some expectations and rules from me and from you so that we can handle any possible conflict that arises, and these will arise, okay? It's almost always, a simple misunderstanding that can be fixed with a laughter, and we can all move on, okay? So, look at my small font here. And I will distribute these slides to you after the class, but you do have access to the slides from last year. So if you want to get a head start, you can look at the slides from last year. Typically, there's incremental changes from year to year. It should be sufficient for you to kind of get an idea of what I will be talking about next time. The course website is primarily on Canvas. Everything is going to be on Canvas. Okay, everything is going to be on Canvas. Your homework assignments, the front page on Canvas is going to be updated regularly. Will contain information about the exams, etc. So make sure you check that. Make sure you have access to that. Make sure everything is connected on Canvas. And I will also record my lectures. I will try to record them every time. But sometimes a battery dies and I end up without audio, But you're coming here in person. So thankfully, you'll be able to see the lecture. If not, you'll look at the lecture from last year, okay? But I put the lectures on YouTube because it's just easier to store everything on Google, right? It's the best free storage, right? Put all your videos on YouTube. You can hide them if you want, but like I put everything on YouTube and delete it on my local storage. Let them worry about the storage, right? But then I put a link to the YouTube video on the Canvas page. But you are also welcome to subscribe to my YouTube channel. A little bit about that in a minute. So this is an in-person course, and you are expected to attend class. And like I said, I'll do my best to, I will record every time. It takes me like the 10 minutes set up 70 cables to deal with. I will do that every time, but occasionally there's a technical difficulty, unfortunately, and we lose a recorded lecture. So don't rely entirely on the recorded lectures. Come in person. I want to see you. I want to get to know you. I want you to know me more, and I want you to learn in my class here in person. The lectures will be posted on my YouTube channel, Professor Saad Explains. Okay, and the slogan is actually inspired from Utah. So what's on the license plate in Utah? Utah Life Elevated. Just teaching elevated, right? So anyway, that's a little corny and cheesy, but please subscribe to my channel. Tell your friends, your enemies, your family, everyone to subscribe. Hit the like button, because that tends to trigger the algorithm, right? And then it drives more people to come and watch these lectures. I see people from all over the world come and they send me messages, they send me I don't know how they find my email, but they send me private emails. And because I'm such a nerd, I respond to these emails. I engage with these students. Like there was a few years ago, this guy trying to solve a fluid mechanics problem, and he sends me the problem. It's like, this is a fascinating problem, and I want to help you solve it. He was trying to cheat, so I ended up solving the problem. I didn't give him the solution. I gave him pointers, but this is like the best thing ever, right? To see that, with such minimal effort, you can reach the world, right? So click like, whether you like the video or not, okay? Click like to trigger the algorithm. Subscribe today. Just go youtube.com/Professor Saad Explains. Click that, button, subscribe, and you'll get alert every time I post a video. Every now and then I post a funny video, and so you'll be in on that and see kind of what's going on behind the scenes, okay? I will communicate with you only through Canvas about this course. It is because I want to pay attention to your needs. You can email me to my work email, but I guarantee you will not get a response in a year, maybe. You know how many emails I get on my work email? Every morning I open up, it's what you get on your emails. This is all sorts of spam and messages and this and that, and I do select all, delete, because if there's something important, someone will send me a carrier pigeon or come and talk to me or give me a call, okay? So I will almost always not pay attention to your message if it comes through my regular work email. But Canvas has no spam. If I get a notification from Canvas, it's coming from you, and you're important to me. Okay, so I will, and the TAs, if it's not a private message, me and the TAs will get to you. Typically, our turnover time is about 24 hours, but we always respond within the hour. Okay, that's kind of my goal, respond within the hour, even sometimes at midnight. I'm prepping the lecture the next day, and I get a message at 11 p.m. before the homework is due. I'm like, my wife tells me, don't respond, because she's also working on her course. Like, no, I have to respond. I end up responding, right? But, communicate through Canvas, anything course related. Now, if this is something a little more personal outside of the, something personal, you want to have another discussion, send me and say, hey, can I set up a meeting? And then we'll take it from there. I'll give you my top secret email to communicate with me outside of the Canvas, but anything related to the course, even if you have an emergency, you're gonna miss an exam or something, just email it through Canvas. You don't have to copy the TAs, just send it to me directly, but everything you have to copy the TAs with homework assignments, any questions about, so that we have more chance to answer you. It'll be me and the two TAs, there's a more likelihood that one of us will respond to you, okay? Office hours, I'm going to do them before class on Thursdays from 12 to 1:30. We can have lunch together. You can come have lunch in my office and we can talk. You know, and we'll see if people find this to be difficult, I'll change this. But definitely, I'm always available by appointment, and I can do Zoom as well. If yes.
So a lot of us that are in this class panel, we have a process right before.
Perfect. Thank you very much. So I will change that. Okay, I will change that. Maybe I'll put it on Wednesdays, or move it after class. But I also don't want you to be too exhausted, right? Because Thursdays is going to be the date for when your homework is going to be due. And I know many of you are going to be working because you have 7 days for the homework. You're going to work on it on the last 7 hours. So you're going to be, I was in your shoes and I know how it goes, but we have to give you the 7 days. If I give you the 7 hours, you'll work on it in the last 7 minutes, right? So I'll change that, but I'll try to keep it on Thursdays because that's when most people, where I find most people need help. But thank you for telling me that. Lisa. Okay. We can do Zoom, etc. Let me see if I'm talking about that a little bit below. So I want you to come with clear questions, whether to me or to the TAs. So I haven't introduced the TAs yet because I don't know where they are. I'm still looking for one more TA. So we'll have both TAs assigned by Thursday, and we'll have 4 help sessions. But whether you're meeting with the TAs or me, please come in after putting an effort, after having put an effort. I always tell my students, look, I cannot teach you anything, okay? Because I cannot learn something for you. You have to learn it yourself. And to learn means you have to run through a trial and make a mistake and figure out what the mistake was and do it better next time and do it better next time. So I can't learn the topic for you. My job here is to tell you what concepts are important to learn for statistics, to try to lay out the curriculum and the structure for you and deconstruct complex ideas with simplicity. But your job is to learn the material. You can't expect to come to class and leave and that's it, you learn. No, you didn't. You have to go, and if I am putting in, so when I first designed the course, you ask any professor of engineering, there's at least 10 to 20 hours of effort from the instructor for every hour of lecture. And I'm not kidding. I hope one day you'll become a professor in engineering and you'll see what it takes, especially if you want to put good quality material out there. The second year, it's not 10 hours per lecture because you already put the effort early on, but still, the next time you're teaching it, you're putting it, like today, I was working on this for the last 6 hours because I was restructuring everything, cleaning things up, right? And so if I am putting that effort into this material, at a minimum, you need to put a similar effort. But you'll be more focused on what you need to do, right? But you have to put the effort. So when you come to me, don't come and say, repeat the lecture for me. I'm gonna tell you, I can't repeat the lecture. My answer is going to be, go review the lecture, please. And don't be upset by that. Because that's what's fair, that's the reality. It's like, you have to put in the effort, and then come. A good question would be, and I'm not trying to prescribe what questions you can ask. You can ask whatever you want, and I'll tell you like, hey, go spend some more time on this and come and with a more specific question. Specificity is key. You could come and say, Professor Saad, when you were talking about greater than or equal for the p-value, I didn't quite get what you did here when we didn't have a boundary on the right. I'm like, oh, great. Okay, let's sit down and untackle this and figure this out. Versus coming, I don't understand anything about the p-values. That's not a specific, I don't know what you didn't understand. Like, should we go back and do multiplication from the beginning? I don't know, right? So you gotta come with a specific question. And same with the TAs. And the TAs, they are instructed to tell you that because they need to serve all of you. So you cannot occupy their time. So typically they come in, they'll help you the first 5 minutes and then, okay, they'll tell you, okay, you're good. Continue doing this work. I'm gonna go help another student. And then you do some work and then you get stuck, then you come back to them. But the key is putting an effort and being specific with your questions, okay? We will have 4 help sessions. Tentatively, these are the hours, 1 to 2, 4 to 5. on Tuesdays, and 1 to 2, 4 to 5 on Thursdays. These came from a lot of statistical data from teaching numerical methods and other courses, that these seem to be the best times that we can capture almost everyone. We never capture everyone exactly. Some of you don't need help sessions, some of you need, and they cannot make it. So then we'd have to schedule meetings, etc. But you have to, I don't know if you're struggling or not. You have to come and tell me that you're struggling with the concept, and we'll be happy to set up meetings with me, with the TAs, whoever, and we'll help you, okay? We'll make it up for you. But we will plan on having 4 help sessions. Those are tentative times. I still need to work with the TAs to make sure they can commit to these times. I know Ashton, he was in my numerical methods and my statistics class last year. He will be one of the TAs this year. We'll also have 1 grad student. We're just finalizing the paperwork there. And like I said, when you need technical help and support, always only through Canvas, and copy me and the TAs on the email so that one of us will get to your question. So we are on the TAs, I tell them, check your Canvas, because they also have courses and they're also studying towards their degrees, right? And they're busy, and I tell them, okay, you check the Canvas from 8 to 9 in the morning and 7 to 8 in the evening. The other TA checks it from 3 to 4 and 10 to 11, and I'm checking it around the clock or in the other times, right? So one of us will get to your question, okay? But they're not there all the time, but that's why I ask you to copy everyone so that one of us will get to you, okay? Now, I did not put a textbook because I will give you PDF copies of the book. Okay, but they're not like super high quality because I couldn't access like really nice quality, but I'm only selecting chapters from this book, from that book, from that book. The primary textbook I used was Beginning Statistics by Warren, Wiley, and Denley. And so this is, you can get any edition, really, if you find like a used copy out there, get that. If not, you don't have to. I already have the chapters on Canvas under Files. The first 5 chapters are there. After chapter 5, I start blending from other textbooks, which I will also upload as the time comes. Okay, so it's up to you. It's sometimes, I like to have a physical copy where I can annotate on, etc. It's a very dense textbook. It talks a lot about, gets deeper into other topics on statistics. It has a lot of other stories, good graphics, good examples. So you're welcome to get it, and I'm not requiring a specific version. They're very similar to each other. So if you find a used copy on eBay or whatever bookstore, just get that, or just use the PDFs I'm sharing with you. Okay. Any concerns, comments, questions, clarification? Yes, Sam.
This concern has already been said, but on Tuesdays and Thursdays, 1 to 2, most of us have a class during that time.
Okay.
Processor control.
Okay. Yeah, because this was never the case. This was never the case before. So we'll change that. Thanks for pointing that out. Okay. So yeah, that's going to be consistent with the office hours situation. Okay. Yep. So that's with Professor Daisy, right? Yes. Okay. Okay. We'll change that. Thank you. Okay, homework assignments. There will be up to 10 assignments. Last year we did 11. I will drop the lowest 2 assignments. So please don't ask for an extension, okay? If you're like, I'm tired, I'm exhausted, I don't want to do this homework, etc., it's going to be dropped. Okay, I'll drop the 2 lowest homework assignments. Now, if there's a extreme situation, an emergency, a family emergency, talk to me. We'll have a discussion, we'll figure something out, okay? Always. If you've taken my classes before, I'm super flexible, super human being, okay? But in general, if it's not a non-valid reason, like the radon spiked in my home today, I had to run out, right? I'm not gonna do the homework. That's not a valid reason, okay? Just take the hit. If you feel you don't wanna do the homework, take the hit, and 2 of the worst ones will be dropped anyway. So the assignments will be posted on Canvas, and you'll get a notification. I expect you to submit your homework solution on Canvas as a PDF. Now, some homework assignments, I will ask you to do them as a Jupyter Notebook. You've done Jupyter Notebooks in numerical, I assume? Okay, good. So I will ask you specifically to do them as a Jupyter Notebook. Or you might choose to say, you know what, Jupyter Notebooks are really cool, which they are. You know, you can do LaTeX stuff in them and just typeset. Do everything in Jupyter Notebooks. Just send me the PDF, okay, when you submit it. Now you can do most of the assignments, you can do them in Word or Google Doc. And that's fine with me as long as you write clean math. Okay, I don't want you to write your math. I want you to use the equation editor. Whether in Word, there's a built-in editor, in Google Docs, or the most superior one in Jupyter Notebooks. You can use the full LaTeX ability. Okay, but I want you to write clean math so I can understand what you're doing. I'm not going to prescribe to you on most assignments. They're going to be either Word or Notebook because there's no coding. We will be using a lot of spreadsheets, as you will see. It's just easier to do the statistics, the type of statistics analysis we want to do. So as long as you upload the PDF, if it's a Jupyter Notebook, I will require the notebook as well. Okay, so we have a source if something comes up, but we will grade the PDF. Okay, we will grade the PDF. Okay, so upload the PDF. Okay, the assignment. Now assignments will be assigned on every Thursday. We'll miss a couple of Thursdays depending on exams and spring break, Easter, etc. And is due on the following Thursday. So you have 7 days, and then if you can still do a late submission if you want. Let's say, you know what, you need 1 extra day, and you just take the penalty. There's 25% daily penalty, so 3 days essentially. Otherwise, it's not worth it for you to submit it at all. If you have a formal CDA form, you know what that is, and then we'll work with you on that. And the homework will be extended no more than 3 days. In general, solutions are not provided. Some of them will be discussed in class because many of the problems are open-ended, and so each of you will have different answers. Assignments will receive some partial credit, and I'll discuss that in a little bit. But I want your assignments to look like real reports, like professional reports. Okay, I don't want them to look like notes that you scrambled while you're walking in the forest and thinking about the universe. I want them to look like legitimate reports, like you would expect from me. I'm delivering some slides. You need to look at the slides clean, presentable, right? I expect you to deliver reports that are readable and understandable. I'll show you an example template in a bit. If your homework assignment has coding, and I used to do this in numerical methods. This actually slide comes from numerical methods. If your homework has coding in it, a print statement from the code is not an answer. Imagine that I don't see, so this is a for loop that does a sum and prints the sum. Pretend I don't see this. What you need to do, you need to take this answer and put it in a markdown cell and say, as shown above, the solution is 15, etc., etc., etc. So I need you to interpret the result. You are going to be the engineer who is going to provide solutions to people. You need to interpret the results. Okay, you need to give you hire a plumber, come and tell you, your pressure is 7 psi. Okay, what do I do with that? Like, tell me, you're the plumber, right? You're the engineer. You need to tell me about your answer. What does it mean? What do I do with this answer? What decisions can we make with it? Okay, simple interpretation. Again, I'm not asking for a Shakespearean discussion about things, just a little interpretation. Okay, goes a long way. Formatting, again, I like you to be creative in your reports. Do whatever you want as long as it has structure. Like your name, title, unit, etc. Problem 1. This is what we're doing in this problem. We're trying to analyze this and that. So have a discussion, right? Pretend this is a report that you have asked someone working to fix something in your house, right? And they're submitting a report for you. You need a detailed information, right? So I put an example here. This is a Jupyter Notebook example. It doesn't have to be a Jupyter Notebook, but if you use a Jupyter Notebook, this is what would do, or you can replicate it in Word. You have a title, your name, This is not my unit, okay? Your unit, and maybe a little description here or not. Problem 1, question 1, we are asked to do this and that. My solution is we compute the error, we first need to compute this and that, or to compute the standard deviation, we first need to use the sample standard deviation formula because we were using a sample, etc. So have a discussion, okay? Tell me your thoughts, write it down, explain, okay? So that it looks okay. The first homework assignment, we're going to be a little forgiving, but moving on, because I'm not only teaching you statistics, I also need to teach you an engineering standard. I need to hold you up to a standard, right? It's not acceptable to have just reports that look like just scrambled notes, okay? And I can really tell when ChatGPT writes some text, even Gemini, it's so cheesy and like so try to limit the use of that, please. Okay, maybe if you're trying to say something and you want a better phrasing, yeah, run it in the GPT, get a better idea, a better way, and then rewrite it a little bit. But I don't want GPT to give me the answer. Okay, and there's the AI policy in the syllabus. But in the end, you are going to be held accountable for that. You can put the problem in GPT and it can solve it for you, but you learned nothing. Okay, it's not going to hurt me. It's only going to hurt you. Okay, now you run it through GPT, gives you an answer, and then okay, why? Then try to work it yourself. Okay, use it as a tool to help you learn, etc. But if you just run it through GPT and put the answer, whether I detect it or not, I mean, yeah, most of the time I do, and we can figure it out. But some of the times we don't. But what did you win, right? Well, you got a grade, you passed the course, and then what? You learned nothing, right? So it's not worth it. For the partial credit for homework assignments, there's very limited partial credit because, so I took this from this very famous professor in chemical engineering, Richard Felder. He set the standard for education in chemical engineering. And I personally met him, and he personally taught me. And he said, you got to get something right in life. Like, what do you mean, great sir? And he said, well, with the homework, you have time. It's like a project. You have time. Well, get it right. Okay, so we limit the amount of partial credit on homework assignments. There will be some partial credit, but it's very, very strict. Okay, so if the method is correct and no errors, you get 100% of the value. If the method is correct, but you have a minor programming or arithmetic error, you messed up the multiplication. Well, you should have done it right because you had time to do this and you had time to double check your answers, unlike an exam, right? And so you'll lose 20%. That's a lot per error. On an exam, on a handwritten exam, maybe you'll lose half a point because you're like stressed and trying to juggle papers and calculators, etc., right? So that's the policy. I'm not trying to justify it, but I'm explaining the reasoning, right? Because you'll understand this. If the solution contains a minor theoretical error, that's a 40% per error. And minor theoretical error, that sounds a little subjective, right? And it is for the most cases, but what you'll learn later, like in calculating the sample-based standard deviation, you used n instead of n minus 1. Okay, to me, that's not a typo, that's a theoretical error. It's not a huge theoretical error because you did use the formula for standard deviation. You just used the wrong one. Okay, and you need to know better. So you lose 40% for that. And then if subsequent questions depend on this, you will not lose points. So you did this wrongly for question 1. We'll take that answer, we'll carry it through on the other questions, okay? But you lose points on that question only. If no discussion is included and we cannot interpret the result, then no points will be given. Like if you put a table with a number, it's just a table and a number. I have no idea what you're talking about. You're not going to get any credit. If we can interpret it, yeah, we'll give you credit for that. And this is particularly important with coding. When I have coding assignments with coding, I'm like, I see just code with a print statement. I have no idea what's going on. because I'm not going to debug the code or read the code. That's done during office hours and help sessions, okay? So if we, even in extreme cases, we'll try to make the code run, but if we can't interpret what's going on, you're going to lose credit. Now, if we can interpret the results, but no discussion is provided, you lose 50% for that, unless the discussion is provided at the end, and all other errors will result in no credit for the question, okay? So it is what it is. I've never lost a student. People figure this out and move on, and it'll be fine. And with the dropping 2 homework assignments, it goes a long way to figuring this out. I like to do quizzes every now and then. Initially, I'm like so motivated to do a quiz every week, but then by the end, it's like every 2 weeks we do a quiz because there's a lot of material to cover, etc. But initially, just to establish a good standard that you need to review your notes, you need to review your lecture before coming to class because there's a quiz, right? And so, it gets that tradition established. No cell phone or chat. Like if you want to take a call or just step out of the class, please. It's disrespectful. It's disruptive. I know many of you are between lunch breaks and whatnot, so I don't mind if you're having your snack or your food. Just share with us. I'm joking, but like with the phone and chatting and like just step outside, please, if you want to have a discussion, a side discussion. Otherwise. No phones, etc. Unless I ask you, hey, would you Google this for me? Then just grab your phones and do that. If you are sick, let me know. You're better off just recovering at home, couple of days, fever, coughing, etc., and then come back, and everything will be fine. For exams, we will have 2 exams and a final. Exams can be either of the handwritten type or the online type. Online type means they're on Canvas. Handwritten type, you're going to handwrite them, use pen and paper. Most likely, they'll be online. We'll see this year. If they are of the handwritten type, you're going to get plenty of partial credit because you'll have a few heavy-duty questions. If they are of the online type, you'll get a lot of low-stakes questions where the answer is either yes or no, true or false, right? One number or not. So there's not much room for mistakes or making errors. You either get it right or wrong, but they're very low-stakes questions. Typically take a minute each to solve. A lot of questions about understanding the material. Difference. For example, I'd ask the difference between sample standard deviation and population standard deviation, sample mean value, population mean value, etc. And so if they are of the handwritten type, you'll get plenty of partial credit because there's like 2 big questions usually. You're doing a lot of arithmetic and algebra, so you carry over mistakes. But with the online exams, there's no partial credit. You either get it right or wrong. Usually it's 1 point each question or 2 points, right? So there's not much room for partial credit. Exams 1 and 2, those would be the midterm exams. They typically cover only recent material. So from today until exam 1 goes on exam 1. From exam 1 to exam 2 is what's covered in exam 2. And the final is comprehensive in the sense you still need to know what a population parameter is at the end, right? But I'm going to focus on what we covered in the last part of the semester. But you still need to understand the concepts we covered in the beginning, right? So there will be much more focus on the material we cover at the end for the final exam. In exams 1 and 2, you'll get a double-sided letter-sized note sheet. So no open books except your note sheet. You take notes in it, but you'll be allowed to use the calculators, the spreadsheets that we build in class, or if you used Python to build those, or if we use Python to build those calculators, you'll be allowed to use them. Super useful because you don't have to reinvent the wheel. We will be focused on just getting an answer. For the final, you'll get 2 double-sided letter-sized note sheets. Please make them legible. Nobody does that every year. I had one student with a magnifying glass to look through because he had typeset everything at like font size 8 points. Nothing was readable, so he had to use this magnifying glass. Just use a legible font. You can type them, you can put them on slides, you can screenshot from my slides, put them together. I don't care, whatever works for you. My recommendation is you put the concepts that you've missed or that you feel iffy about on those note sheets, but you know better. This is my tentative grading strategy distribution. It's always a challenge. Should we put a lot emphasis on assignments, on timed exams, on quizzes? This has been a good approach for me over the years. Assignments 35% and quizzes 5%. The two midterms are 35%, so 17.5 each, and the final is 25%. And this is what the grades would look like. So you can look at this, so you see where you're at throughout the semester. I'll talk a little bit about my teaching philosophy. Whose attention span is no more than 15 minutes? Like when you're watching a video, yes. Okay. So is your attention, for the others, is it more than 15 minutes? That's great, because then I can bombard you with slides all day long. No, really, like when you're watching a YouTube video or a lecture, like if I cannot get my concepts in 15 minutes, you lost me, right? Unless I'm like in total immersion, 100% focused, and I get it. You get tired, you get bored, and typically what happens, this is what attention span looks like. So, the beginning of the lecture, you're settling in, etc., and then teacher says something exciting, and your attention peaks, and then after that you lose interest, and then you get tired, you sleep, you eat, I don't know, you daydream, and then, it's the end of the class, let's wake up, and we leave, okay? So the challenge is to break that pattern, and it's not always perfect, and we cannot always do it because there's material to cover, right? I wish I can do entertaining videos on YouTube like, what is statistics? Oh my God, I learned so much today from this exciting video where they only talked superficials about statistics. But you're engineers, you need to learn the technical know-how. You need to understand the boring and gory detail. So my job is hopefully to try to make it exciting throughout. So what I will attempt to do is something that looks like this. It's like every time we feel that we're losing interest, etc., I'll sprinkle in an activity or a story or a break, a little laugh here and there. So that's my teaching approach. I tend to talk a lot. I love humor. And so I know my humor is probably outdated now, but if you are well-versed in, culture, and American culture is not my primary culture, so I had to learn a lot about American culture as well. And so, if sometimes I throw something might not get it in the first time, but I guarantee you there's a little humor in there. So we'll see how that works. That's at least my goal, and the student body has to be receptive, right? I don't know. I cannot tell now. You're more outspoken than some student groups I've had. So I have hopes that. Because this is going to be, I also get bored if I don't hear back from you, right? If I'm just talking to statues, right? I'm like, okay, why am I doing this, right? So think of it from my perspective. And the more you engage with me, the more I'll engage back with you and the more exciting the class will be, okay? So it's a two-way street because I also suffer from that, all right? So we'll do an activity, a story, a laughter here, a break there, a review, something. Okay. This is a huge philosophical point to me, and I argue with my colleagues about it. It's very pedagogical, but kind of, beyond the point. But my approach is inductive. So I like to teach, and I like to learn like babies learn, like kids learn. They walk and tumble. Like, if I don't step over this little, step here, I'm gonna trip. So next time, the kid will, or like when they go up, up the stairs and they throw something at mommy, right? Like, things fall, right? And they start learning more about gravity, right? And they develop and understand. I like this approach. This is called an inductive-based approach. We learn by little examples here and there, an example here, an example there, and we try to build a theory, okay, about what's going on to generalize it. That's the inductive approach. The opposite is called the deductive approach, where I come and give you this is the general formula of the universe, let's apply it here, 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 and there. And you're like, where the heck did you bring this formula from, right? Well, okay, there's room for that deductive approach, but I think the inductive approach, for me at least, makes me a more effective teacher and makes the students engage more because we're trying to understand what's happening, right? This active learning approach, we'll see if we will implement it this year. Normally, I would ask you to form into self-select into groups. Oftentimes, it just doesn't work. And so, you know, I might not, maybe not this Thursday, maybe next Thursday, we'll talk about it. Just, I want to see how you guys are reacting to me and to each other, okay? And I like storytelling a lot. And that's why it was important to me to tell you my voice, because I'm being repaired right now, so my voice is not 100%. I get tired quickly. So, but I use a lot of changes in voice. Sometimes I'm loud, sometimes I'm quiet, and etc. Because that tends to grab your attention, to wake you up, and so on. So don't be surprised if you hear that. You might not like it, and that's fine. That's the challenge with mass education, right? Versus just kind of one person. I have to try to meet everyone's expectations, but it's impossible because you each have different learning styles. So, you know, something will stick in. I guarantee you that something will stick in. So, a few last things. So this class is about statistics, not programming, not coding, not spreadsheets. It is about statistics, okay? To do basic stats, you will need basic software tools, like basic stats, like mean, plotting a distribution, even doing some elementary hypothesis testing. We can do those with Google Docs and Google Sheets. And if I have time, I will show you how to do them in Python as well. But it's an overkill to use Python for that. We can do all of this stuff in simple Google Sheets. Now, the disadvantage of the Google Sheets or Excel is that the cells are cumbersome. You click on the cell and you have to type in a long formula in this kind of single line. It's just horrible. But once you type that in and you got that right, then you're good to go. Okay, in Python, you have this big cell where you're typing your formulas. You can see them cleanly, but there's a little bit more of an overhead, a barrier to just get all the libraries that we would need to get things working. So in numerical methods, use SciPy root for root finding, right? So here we would be using scipy.stats to do all our statistics if we're doing Python. Now to do serious stats, you need good programming skills because that's where you will need, you're dealing with big data, like the data for radon, no way you could do it with Google Sheets. It would just crash. It was 8,000 data points, right? You do it in Python, you import the data file, and et cetera, and you process it there. We will work together on, if there's any programming, we'll work together, but you need to make a serious effort. It's not a big deal here for stats because you already have good exposure to homework. If you allow me 2 more minutes. And then, like I said, for the lecture, so review notes prior to the lecture, review notes of the previous lecture. And if you want to look ahead, check the slides from last year. Like I said, because I'm building the slides as I go, and it takes me time to build the slides while I'm driving here, right? Don't do that. But I will do my best to post the slides earlier. But you can look at the slides from last year if you want to get a head start. But definitely review the slides from the previous class, okay? Just a couple more minutes, please. And I'll talk about this next time. What you need to do today is review your syllabus, read the syllabus, understand the class policies. Nobody reads the syllabus. You know what? Try to read it. There's a lot of information there, I know, but you know, it might answer all your questions. Install Python if you haven't done so already. Make sure you can access Google Docs, Google Sheets, or MS Word. Subscribe to my YouTube channel, please. Make sure you can log into Canvas and make sure you receive announcements. In the settings, there's turn on notifications. Okay, you are responsible for getting notifications about homework, etc., and messages. So make sure you turn those on and find out where the help session is. Familiarize yourself with the space. It's the Google Center, we used to call the ICC, and find out where my office is and stop by and say hi, introduce yourself. I'd like to remember you by name. Just come in, say hello. You know, I hated the class today. By the way, my name is such and such, right? Or I like the class, so, okay? Let's have a great semester. Godspeed.